We now know how to draw basic Lewis dot structures and understand that some elements, like carbon, nitrogen, and oxygen, will strictly follow the octet rule. But many elements will not follow the octet rule, and some types of molecules will not follow the octet rule even when they involve the more common elements that typically obey the octet rule. The first example of this violation is free radicals. These are species with unpaired electrons, otherwise known as odd electron molecules. They will end up with an odd number of electrons around one of the atoms, which means that atom will not follow the octet rule, such as with the case of nitric monoxide, which has only 7 electrons around the nitrogen atom. Another example arrives in the form of some electron-deficient molecules that lack an octet for the central atom. Elements like boron and aluminum only have 3 valence electrons, so they can only make 3 covalent bonds. In boron trifluoride, boron makes 3 bonds to fluorine, so it will have only 6 electrons around it rather than 8. This is a violation of the octet rule. And lastly, while elements that follow the octet rule will be tetravalent, meaning they will have 4 coordination sites, there are also hypervalent elements like phosphorus and sulfur. These can have 5 or 6 bonds respectively, which exceed the octet rule in terms of the number of electrons that can be found around a central atom. This happens because these elements have access to d orbitals, whereas elements in period 2, like carbon and oxygen, do not. Then, of course, we know that hydrogen only needs 2 electrons around it, and most of the metals on the periodic table will not follow the octet rule. So the octet rule is less of a rule and more of a guideline, since it really only applies to a handful of elements on the table. However, those few elements, like carbon, nitrogen, and oxygen, are the most common elements in organic compounds along with hydrogen, so the octet rule does end up being very useful in describing bonding for most of the molecules inside living things.